Bueno, muchas gracias. Gracias a toda la gente de Ekoparty. La verdad es que es la primera vez que estoy por aquí y me está gustando muchísimo. Así que tenía la espina pendiente de venir a la Ekoparty y me la he quitado con ganas. Me llamo Javier Marcos, soy ingeniero de seguridad en Facebook y ahora mismo estoy en el equipo de ingeniería de Osquery. He estado en respuesta a incidentes, he estado también como analista de cibercrimen. Entonces, más o menos tengo un background ofensivo, defensivo, que viene bien cuando estás haciendo un poco de respuesta a incidentes o generación de señal. Y, bueno, la charla, vamos ya para allá. Y, bueno, este es Ted.
Yeah. So, unfortunately, I can't speak Spanish, so I'll be speaking in English, and we'll try to go back and forth. I can understand a little bit, so we'll try to transition well. Awesome. Let's just jump right into it. Why do we want to be here today? We want to kind of share our experiences building an open source security tool. So this is a tool that a lot of companies deploy. We hope that we build it securely and that the whole entire process of building is hardened. If anyone were to attack our build infrastructure and inject any code or add any binaries to the packages that we deploy, they could kind of systematically take over a couple companies, right? So hopefully that we detect that. So we want to show those examples of how we have hardened our build process and hopefully present some new ways of attacking and defending continuous integration. So the title of this talk is kind of Secure DevOps, and DevOps has been traditionally attacked as not being secure because it takes out all of the security engineering from the developers just landing their code and running it in production. So that leads us into our motivation, what we want to get out of this. We want to continue to build like awesome open source tools. Like in the open, we want to develop everything that we run at Facebook in the open so that people can continue to audit it. We have an awesome white hat program where we ask researchers like yourselves to come and try to attack the code, try to test the code, and then hopefully we pay you if it's awesome. And also, we want to encourage feedback from you. If we do anything wrong, if you see us doing anything wrong up here, please tell us about it. And there's a lot of things that we do at Facebook to keep everyone that uses Facebook secure, as well as all the code that we produce, keep it secure. So something like Thrift, the Thrift APIs, or React Native, if you've used any of those frameworks. There's a lot of things that we do to keep all that secure. If you have any questions about this, any of these parts, please come up, ask us afterward. We'll be happy to talk to any one of these. So we use tons of open source software at Facebook. Like I can't think of anything that isn't. I'm sure there's a couple things that aren't open source, and we also try to open source everything that we build. So if it doesn't make sense to open source something immediately, what we'll do is create a timeline to eventually open source that. If we can, every time we're going to start a new project, we will begin that in the open so that entire thing starts in GitHub. GitHub is our weapon of choice. So our security engineers and all of our engineers themselves, like whether they're data engineers, analysts, we want them to perform, like spend all their time doing analysts, like looking for threats, trying to understand compromise, and writing integrations around all this open source software, right? Making sure it all plays together nicely. That's the optimal use of their time. So if you want a really good introduction to everything that Facebook does in incident response, this is a great talk at RuxCon last year. Actually, this year, someone is also at RuxCon talking about how we do red teaming and purple teaming. So immediately following the end of Ekoparty, check out the slides that they produce. This is a step-by-step like tutorial on how to create an incident response team, and all of those strategies and examples we use inside of Facebook too. So this is like why we do open source. At the end is the most important thing. Like I don't want to run any tool on my laptop that's going to give visibility. I don't want to run an antivirus agent unless the code for that agent is open. And it has been audited and it has been looked at like people like yourselves, right? So that when there's a problem with that, because there always will be vulnerabilities with that, I want to see the patch come in. I want it on my laptop as soon as possible, right? We actually have 132 projects out on GitHub. Of that, there's 46,000 forks, right? So 46,000 people have taken these projects and they're using it themselves, they're customizing it themselves. It's very important that we keep all of these kind of like well-maintained. 91,000 commits. All of those commits are reviewed, code reviewed by someone at Facebook. And of that, about almost 300,000 people are looking and actively using these projects. That's total. That's not like a daily value. That's total. The Osquery project, of that, is about 5,000 people. There's about 2,000 commits and about 500 forks. I'm not sure what's going on with that forks, and that's only one. So this is what we're going to talk about for the rest of the talk, is how we secure this project itself and how we make sure that every 2,000 of those commits gets code reviewed, gets built, gets static analyzed, gets dynamic analyzed. And where we are with the project is about a year, and October 29th will be the 1-year mark from when we open sourced it. But if you go into the GitHub repo today, you can see everything back into June 30th, which was the first commit in the project. So if you want to do a code review of any part of the project at any time, you can absolutely do it. The project, to talk a little bit about it, and I'll get just a little bit so you understand like why it's so important that we secure this. It's a host visibility tool to let you explore your operating system with SQL. So you use SQL to explore processes, the cron tab, listening ports, open sockets, open files, so forth and so on and so forth. And it does this without any like forking or execing to bash or grepping and piping. And that was very important because we want to deploy this to every operating system that we maintain. So we're not really sure if it's going to be a GNU bash, if it's going to be it's not even going to have bash, or it's not going to have grep, or it's going to have a different version. And plus, we don't want anyone to inject anything into the commands that we would be forking or execing. So it's 100% API usage, 100% OS API usage. And this kind of makes sense. The reason we do it in SQL is because most of the things that are on the operating system can be expressed as tables. And then we can take those operating system concepts and we can use the same like logic, the same SQL across our Macs, across our Ubuntus, across our CentOSes, across our FreeBSDs. We don't have to know the intricacies of like this is a thread ID, that's a process ID. And then most of the developers and administrators, the people that we hire that will be like sysadmining our tools, they kind of understand SQL. They've interacted with databases, they've interacted with SQLite. Like a lot of presentations that you see today have had some portion of SQLite, so we all kind of are forced to know it. And it kind of works like this. You take processes is the concept. There's a function that generates the processes. We take common attributes across all the operating system, call those the columns. And then if you want to see all the processes that aren't running by the root user or the zero user, you can just use a where constraint. And then if you want to get more awesome data from that, like say the username, you could check the users table, join the UID from all the running processes and their credential to all the users that are configured on the system and the canonicalized username that they're given. There's about 100 tables here, so lots of parts of the operating system. This is very important that all of these things are kind of fuzzed too, because we're pulling into different OS APIs that most people really don't look at very much, and maybe they only interact with the command line interface that uses the OS APIs. So it's very important that like we do both analysis on the libraries that we're using, but also at the end product, try to fuzz it, try to do static analysis, dynamic analysis. The Clang LLVM framework is amazing for this too. Especially the most recent 3.7, awesome, it's kick-ass. The actual function, like for time, if you want to do select star from time, kind of looks like this. So the query takes the table name, just runs this function. You get this like standard string map pair that returns, and then SQL kind of gives you the integers, the strings, whatever, and gives it in table format. There's a lot of stuff in here. There's like we said, the LLVM integration, we use CMake for our build. C++11, we use so much C++11. We use Thrift as our API back and forth for extending it. So it's just it's like protobufs. And then RocksDB is our key value store. It's actually the same key value database that Facebook uses for tons of things, essentially like multi-feed. So you're using the same key value store to look up little caching data that Facebook uses to cache data to. So it's really fast, but it's kind of hard to build, and it's pretty intricate. And then after that, you get this plugin API, and then from there, you can figure out how to log stuff using this tool, how to config things using this tool. You get a daemon that runs. You can just drop into the shell and start executing SQL. So it's pretty complicated, especially to build, especially for like every one of those 2,000 commits. People are like iterating a couple times, so to build all of that every single time and make sure no one introduced regressions, bugs, and to just run all this static analysis is like really, really intense, right? User.
So, like Ted said, the process. Oh, sorry, perdón, me voy para el inglés, la costumbre. Como Ted ha dicho, el proceso de compilación de Osquery es un proyecto que está construido todo con C++. Entonces, es un proceso complicado, tiene muchas dependencias y de hecho ahora mismo soportamos 10 plataformas diferentes. Ahí está la lista: OS X 10.9, 10.10, 10.11, Ubuntu 12, 14, CentOS 6 y 7, Red Hat Enterprise Linux 6 y 7 y FreeBSD 10. Entonces, cada pull request que entra en GitHub, hacemos un build en cada una de estas plataformas. Entonces, de hecho, uno de los desarrolladores, somos 3 en Osquery, ni siquiera compila localmente. Él manda el código a la integración continua y es lo que hay veces que es en plan, oye, ¿por qué los builds están rotos? Nada, estoy probando unas cosas nuevas. Y puedes encontrarte 20 builds que están rotos porque no compila localmente, directamente lo manda a Jenkins. Entonces, el proceso tiene que llevar, pues, además de la compilación y que ha compilado bien, lanzamos unos test unitarios, lanzamos unos test de regresión para poder identificar exactamente cuándo se ha introducido un bug o un fallo de performance. Osquery se basa mucho en rendimiento. Entonces, siempre utilizamos que la utilización de CPU, utilización de recursos sea la mínima posible. También ejecutamos análisis estático y dinámico y además Osquery tiene una extensión de kernel. Cargar una extensión de kernel dentro de los ordenadores de nuestra flota es un poco arriesgado porque puede cascar y el ordenador de los ingenieros se va a la mierda. Entonces, es mejor que lo probemos lo más posible antes de mandar el código en master. Las herramientas que hemos intentado encontrar, que intentamos buscar para ver cómo esto lo podíamos hacer sin tener que reinventar la rueda, pues primeramente utilizamos Travis CI, antes de ponernos a montarlo nosotros. No funcionó, para empezar, porque bueno, siempre hemos partido una serie de requerimientos que uno de ellos era: vamos a tener un repositorio público y ahí es donde va a estar todo. Siempre va a estar todo público y cualquier pull request que entra dentro del repositorio se va a tener que construir. Eso, para empezar, en Travis CI era un no-go. Te decían, no, eso no puede ser, tienes que tener un repositorio privado. Entonces, para empezar, no funcionaba. Intentamos convencerles y tal, y al final parece que le teníamos medio convencidos, pero aún así seguimos teniendo muchos problemas de rendimiento. Aparte que construimos en OS X, virtualización en OS X, por temas de licencia y demás, siempre había problemas y el rendimiento no era bueno. Entonces tuvimos que optar por construirlo en Jenkins. La gente de Travis CI no estaba muy contenta, pero bueno, tuvimos que ir para adelante y hacerlo nosotros mismos. El proceso básicamente es el siguiente. Aquí un desarrollador, todo nuestra source of truth es en GitHub. O sea, en GitHub está todo nuestro código. Cuando tenemos un bug o un problema, creamos una issue, las comunicaciones entre nosotros y para un determinado problema o un determinado trozo de código está todo en GitHub. Entonces ahí es donde está todo nuestro repositorio. Entonces cualquier desarrollador nos puede enviar una pull request. Tenemos una serie de bots que lo que hace es se asegura de que haya firmado y tal, un requerimiento por parte siendo un proyecto de software libre de Facebook. Entonces eso marca la pull request como firmada y en este momento hacemos una revisión de código y simplemente tenemos nuestro propio bot también en GitHub y lo que hacemos es OK to test. En ese momento Jenkins va y lo construye. ¿Qué pasa? Jenkins funciona, hace la cosa que tiene que hacer. ¿Qué pasa? Que en los últimos cuantos años, y si alguno ha tenido la oportunidad de echar un ojo al código de Jenkins, pues tampoco es que sea el mejor proyecto del mundo en temas de seguridad. Cada poco hay ejecuciones remotas de código, problemas de CSRF, siempre hay algún exploit. Metasploit tiene varios módulos para atacar Jenkins. En muchos de los red teams siempre es encontré tu Jenkins o encontré tu Hudson, game over. Ya tengo una shell, es persistente. Entonces, lo que teníamos que hacer era, lo que teníamos que montar con Jenkins, ¿cómo lo vamos a a conseguir que esto esté montado con un software que no es completamente seguro, pero vamos a intentar mitigar. Y siempre tienes que saber o tener en cuenta, si tienes algo en lo que confías, te lo van a petar. Entonces, ten eso en cuenta, entonces intenta mitigar. Siempre respuesta a incidentes es mejor que algo que te proteja. Para empezar, toda la infraestructura de Jenkins lo montamos en una red externa que está completamente air-gap con la red corporativa. En Facebook tenemos tres tipos de redes. Está la red de producción, que es donde está todos los servicios que básicamente es facebook.com, Instagram, todo esto. Entonces tienes los pops, tienes los edges, esto está conectado a Internet. A grandes rasgos, esta es la red de producción. Luego tienes la red corporativa, en la cual tenemos acceso a Internet, tenemos una serie de firewalls, y después tenemos otro tipo de red que, por ejemplo, tiendas que hay en el campus o determinadas cosas que queremos conectar, están conectadas ahí. Están completamente separadas con la red corporativa, pero utilizan el mismo egress y, por lo tanto, podríamos aplicar reglas en los firewalls. Este fue el primer paso de aislamiento. Después, dado que confiamos en Jenkins, pero tampoco tanto, bueno, para empezar, nuestro Jenkins está en Internet, lleva en Internet más o menos un año, no nos lo han petado de momento o que sepamos. Si alguno tiene algo para decirnos, está todo cubierto por el bug bounty, pero de momento hemos sido capaces de aguantar. Entonces, si tú vas a jenkins.osquery.io, ahí exponemos nuestro sistema Jenkins. Básicamente lo que hacemos es, eso está expuesto a través de una máquina en AWS, en Amazon. Lo que hacemos, utilizamos esa máquina como proxy TLS y como balanceador de carga. Exponemos el servicio de Jenkins que está dentro de la subred que hemos montado en la red aislada de la red corporativa con una shell inversa que expone el puerto 8080, que es el puerto local de Jenkins. Y básicamente lo que hemos hecho es, dado que uno de los requerimientos era que siempre teníamos que construir en OS X, y virtualización en OS X o encontrar un servicio que te ofrezca virtualización con OS X no es fácil, lo que hemos hecho, bueno, básicamente Apple lo que te pide es, puedes virtualizar OS X con VMware, pero te dicen que solo puedes tener 2 instancias del sistema operativo corriendo por cada unidad de hardware. Entonces, por ejemplo, coger los MacBook Pros, los cubos de basura estos que tienen 128 GB de RAM y tal, vale, va bien. ¿Qué pasa? Que no te merece la pena tener una máquina de esas que es cara para correr 2 instancias de OS X. Entonces lo que hemos hecho, lo hemos construido todo con Mac Minis. Y aquí se puede ver qué es lo que, bueno, a grandes rasgos, qué es lo que tenemos ahora mismo virtualizado. Tenemos una serie de máquinas esclavas, todo montado con OS X, con ISX instalado como bare metal, agregado con un clúster de vCenter, con un NAS para comunicación y demás, y Jenkins es parte de este entorno virtualizado y corre dentro de aquí. Bueno, ¿cómo empezó esto? Aquí me veis a mí trabajando duramente para montar esto y que no nos lo casquen. Esto empezó como una prueba de concepto y simplemente para poder compilar y tener todo compilando a la vez. Entonces, esto lo montamos primero. Yo puse un Mac Mini en mi casa y lo tenía conectado a Internet, exponiendo puertos por SSH y tal, y parecía que funcionaba. Entonces, bueno, ahora como podemos, en lugar de tener una compilación cada vez que mandamos algo, queremos tener 5. Y para empezar, bueno, pues empezando pues con un Mac Mini, pasamos a 5 Mac Minis que estaban hechos en un clúster. Esto yo lo tenía en mi escritorio. Era un poco incómodo trabajar con todo este lío de cables y de cacharros. Entonces, además que tendríamos que meter más máquinas, al final acabamos teniendo 10 Mac Minis enracados con un NAS, una serie de hardware de red y demás. De hecho, ahora mismo estamos en el proceso de meter otros 5, o sea que seguiremos expandiendo y metiendo más racks. Acabaremos con un rack entero lleno de Mac Minis. Pero de momento esto ha sido así como empezado. Pues va a pasar virtualizando y poco a poco. Una cosa importante de decir aquí siempre, el tema de DevOps es un concepto que la gente dice, bueno, DevOps, metes una máquina, pones a compilar. Entonces, nunca vas a intentar hacer hardening completo de esa máquina. Siempre te vas a tener algo que no te va bien o directamente utilizas containers que no sabes cómo están configurados. Desde el principio nosotros hemos sido bastante cautelosos en utilizar un entorno completamente hardeneado, que estuviésemos utilizando políticas de seguridad completas y a partir de ahí escalar. Entonces, tardamos más tiempo en montar todo desde cero, pero utilizando técnicas de mitigación seguras. O sea, nosotros podríamos tener la máquina de Jenkins comprometida y nos daría igual, tenemos maneras de mitigar. Y cómo hemos ido añadiendo diferentes capas para poder, pues, en lugar de compilar una instancia de Osquery, bueno, empezamos soportando CentOS, Ubuntu y OS X, ahora soportamos 10 sistemas. Entonces, este es el tema. Y los requerimientos que os había comentado, básicamente aquí está todos los pasos que hemos tenido que ir por ellos. Bueno, básicamente aquí en esta diapositiva lo que veis es un resumen de todos los pasos de hardening o de lockdown que hemos hecho en Jenkins para mitigar los posibles ataques o posibles problemas que podamos llegar a tener. Empezamos con el TLS proxy en Apache en la máquina de AWS, que también funciona de balanceador de carga. Hacemos blacklisting de endpoints, que ¿para qué quieres tener la consola de scripts abierta? Porque eso no te va a dar más que problemas. Si no la usas directamente, no deberías utilizarla. Y otra serie de puntos más que vamos a ir ahora en profundidad. Directamente, el TLS proxy básicamente lo que te hace es, Jenkins utiliza HTTP, entonces lo que hemos para poder ser capaces de servirlo con SSL, lo que hacemos es Apaches directamente, TLS proxy, hardeneado, teniendo en cuenta cómo utilizar los cifrados que puedes utilizar, nada de SSL v3 y nada así. Y luego Moz proxy también para exponer el puerto que está con una shell inversa desde la máquina de Jenkins. Y luego este es el paso de blacklisting, que básicamente lo que hicimos, hemos ido hacia 3 años hacia atrás más o menos, todos los exploits de Jenkins que ha habido, ¿qué es lo que te han explotado? Bueno, pues tenemos una serie de URLs, que esto es lo que te han intentado. Y entonces los hemos tenido funcionando durante una semana o así, y hemos hecho una comparación. ¿Qué es lo que usamos de estos endpoints que tienen algo de riesgo? Pues nada, pues a tomar por culo. Se bloquean y ya está. Entonces, esto es básicamente blacklisting. En lugar de hacer blacklisting, también podrías tenerlo expuesto, utilizar un proxy transparente extrayendo datos de los logs y tal, para ver cuáles son los endpoints que más usas en el uso normal de Jenkins, y en lugar de bloquear las cosas malas, pues bloqueas lo que usas, o sea, dejas abierto lo que usas y bloqueas todo lo demás. Así no tienes que preocuparte de tener que actualizar esto y demás. Pero bueno, esto la verdad es que lo pusimos así al principio y más o menos se está quedando. Si tú vas a Jenkins Osquery.io y te pones cualquier endpoint que está bloqueado o algo que tenga un 404, pues te vas a tener el tigre de Jenkins. Y bueno, hemos encontrado que esto, a veces que vemos un poco de escaneo, gente encuentra esto y o le gusta mucho la foto o no le hace mucha gracia, sigue escaneando. Y a veces que te asusta un poco.
Nice. So that's like the most basic stuff that you can do to lock down Jenkins. To go a little bit farther, here's our setup, and we recommend this for most. And this is like a setup for a couple of the Jenkins servers that we have. This is not just Osquery that's running it. All the Jenkins that are available on the internet, managed by Facebook, are building just open source products. So the first thing we want to do is add proper authorization. And the way we recommend to do this is go to GitHub, create an organization. It's completely free. You can do it as your account. Create a token in there, an API token to access that organization. And then use that to do authentication through Jenkins. So go into the plugins in Jenkins, find GitHub authorization, enable that, and then turn on matrix-based ACLs. Throw in the token that you got from the GitHub API, from this little integration that you created on the organization. And now any GitHub user can OAuth authenticate to your Jenkins. That's bad, so turn on that matrix-based ACL, throw in the couple of admins that are on the GitHub account working for you. Those will be the only ones that can start and stop builds. Everyone else will be the same access as if they were anonymous on the platform. So here's our organization. It's Javier, myself, and our buddy Mike. What we can do now is if we add a new user, so Mike comes along and adds another user, a test user, to the account, we can check to see if that user has multi-factor authentication turned on, the little GitHub authorization via SMS or via the app on the phone. This allows Jenkins to only have admins logging in that have done a two-factor authorization. That's amazing, right? That's exactly what you want. Over there on the side, too, I have circled in red that users that get added to the organization that don't have MFA turned on are only a member and they can't do any admin. So, and then there's a couple of options which have been ignored in most Jenkins deployment. Just go through the security options, turn them on. The CSRF is a big one. Now that we have those couple of admins, we don't want to get them owned. So the whole thing here is just kind of like creating barriers, right? So we don't want our admins to just get their credentials stolen through a fish or through some sort of watering hole. The last thing that I'll note here is there's use a browser for metadata download. I prefer not to turn that on. If you don't turn that on, then the metadata is built by Jenkins itself. It's more trustworthy, but Jenkins has to go out to the internet. Our Jenkins has the ability to go out to the internet and check for updates too, so it might as well grab this metadata itself. This is versus letting the user's browser give the metadata. So the last thing to kind of lock down Jenkins is if you ever need to go in and do some like ground level triage, add multi-factor to SSHing in. So right now we have public key authentication to jump into this AWS host that has a proxy back into our infrastructure that runs Jenkins. Cool, that token is awesome. If someone broke into one of our admins' laptops, they could grab that token from disk. What we want to do is then add a multi-factor there. It's kind of hard to do that with GitHub right now. So we are using Duo, but any type of multi-factor, one-time pad, hardware token will work. Now we turn to like pull request hardening. So this is another couple of settings that we run inside Jenkins, which is anytime a pull request comes up into our open source repos, we don't want to automatically start building that. Like remember what we were saying, our Jenkins has access to the internet. Those build hosts are running on VMs that are inside the ESX infrastructure. If someone posted up code there, we're building C++11. They can do whatever they want with the operating system, right? They don't even have to, right? You can just fork bash and have at it, right? So we want to make sure that every pull request that comes up gets code reviewed first. So this means pull request comes up, someone's happy, bot comes in, says, hey, one of these admins, it pings each one of us, says, hey, can you do a code review? And then we'll reply with, okay to test. As soon as we do that, the GitHub API calls into Jenkins and says, here's the current checkout of the Git repository, please start building this code. So that's awesome, right? That prevents someone from just like blindly throwing up a shell into our repo and having it run, call back, and now they have control of all our build hosts. Right, so this is the kind of message that we want to send if anyone's running their own sort of Jenkins infrastructure or CI build infrastructure. Make sure you have an ability to let your admins do this code review first. This also, like, let's say Jenkins didn't have access to the internet. Someone could still take down all of your build CI by just DOSing the whole thing. That's no fun. Plus, it gives you a chance to like actually look at the code and make sure that it is nice code. Right? There still exists one kind of problem which we'll highlight right here. This is Ekoparty. We have to have some fun. We have to get some shells. This is what we call like kind of the doomsday scenario. So even though we did a code review, there's still ways to get around that. The first thing is you put up this innocuous pull request. It looks good. We jump on. Bots say, hey, can I have this? Can I test this? I reply, OK to test, looking good, pretty. Jenkins comes in and starts building. Then the author of that pull request really quickly does a git commit -- amend, and then they force push back to their branch with that amended pull request. That comes back into the GitHub API and will then call back out to Jenkins and start building again. I did not have to say OK to test here. So they can put in whatever they want. It's not going to be code reviewed, and it's going to start building. They then quickly do a git commit amend a third time or a second time for a third commit. This time they remove whatever they had put in there, and this looks again like this innocuous pull request. So what happens after that is like, I don't know, they have complete control of the build infrastructure. They can run whatever code they want. We didn't review it. Let's assume they get a shell on that an automated shell on that build host. They can start doing layer 2, layer 3 attacks. If they can get access to the master Jenkins, they have now control over all the build hosts. One of them eventually at midnight will build the packages that we distribute. So the kind of like .debs, the .pkgs, the .rpms, they can inject into it, right? So this is the doomsday scenario. We don't want this to happen. So let's try to do it, right? So here's the Osquery, our little bot saying, go ahead, let's start build, right? So we pass that OK to test scenario. Then you git commit amend with this. And here's a little shell echoing into bash, put it in an environment variable so it doesn't show up inside the process listing. And then really quickly again, git commit -- amend, push that back up, and you see there's about 3 seconds between here. There's 3 seconds for someone to be reviewing your code. After that, GitHub does not provide a way to look at your previous amends. If you know the commit hash, you can look at it. It's still on GitHub, but it's not going to be in your history, and it's going to be erased from the pull request history. So you're pretty much sitting pretty. You have a shell in this box, and there's no real evidence in GitHub that you push the shell to the pull request. The first time we tried this, we were like, crap. We just sat here watching our little listener with our really crappy shell, and we didn't get anything out. That was because Javier was pretty awesome, and he put up network access controls so that the build host could only go out to S3 to download dependencies, and then to like apt, yum, and Red Hat's licensing server. So it couldn't just call out to my stupid little AWS host. So we built this S3 shell. It was pretty quick. Actually, took about like 15 minutes, and this calls out to S3 just like we run dependencies there. This is like an attacker-controlled S3, and it just downloads a bucket, executes it, and then uploads into that bucket the std out and the std error. Right. So with this, boom, you can get shell. Now you have access. Now I'm running as Osquery on one of these hosts. It's a Mac host, so all right, I kind of know Mac a little bit. I can escalate into root. On the build host, it's really hard. You type sudo and then your root. And then after that, then I can start like doing layer 2 attacks on the build infrastructure. So what do we see? If we're doing process monitoring on these things, logging all the processes that execute, we see like this. And I don't really know. Jenkins runs a lot of like shell scripts. I don't know if that's bad or good. From the build perspective, I see 3 concurrent builds on all of the operating systems happening. So all of Jenkins is spun up really heavy right now. And from the Git perspective, it's a little hard to read with the lighting. You don't see anything. You actually just see like the couple of files that you legitimately edited in this pull request. Like there's no evidence of this reverse shell. So like we call this the doomsday scenario because like we wouldn't really be able to detect if it happens. So the only thing we can do is really expect that it's always happening, right? And that's how we build the infrastructure. And we didn't really do 5 or 6. That's kind of hard. So what you would have to do in order to like cleverly jump from one of the slaves into master is do one of these attacks or like steal the credential. Right, so if you were able to steal this now, this isn't from the perspective of the internet. This is not like two-factored or anything. This is still just a password to jump into Jenkins. You're looking right at it. You're in that vendor infrastructure. We need to make sure that like a compromised credential or a leaked credential is not going to give you that access, right? So one thing we like to say is like, all right, anytime you build something, think about, is this just one credential, like one little tiny compromise, one leak, one wrong copy and paste, or one like social engineering attack away? If that is, then you're doing something wrong and you need to like rethink this architecture. So we add some mitigations, and I'll give it back to you in a second to talk about these mitigations. But so every build host, if you're building these things, the first thing a build host should do when it comes online, preferably it should be in VMs that aren't online, so you're not taking up resources on your infrastructure. First thing it does when it comes online is just cycle all of its passwords. You don't need all those passwords. You have an agent that Jenkins is launching on there. It's not doing any type of like password authentication, so just cycle all the passwords. This prevents lateral movement from someone taking over one host going into the others that are probably running on the same layer 2. And then this like inner build host isolation. So put your network access controls on the master's point of view. If you can, like VLAN your whole infrastructure to be like Macs here, Red Hats here, masters building there. That's a little intense. You can just kind of put some IP tables rules from all of the Jenkins masters, and you'll be sitting pretty. And then finally, the package building stuff should be isolated. So if possible, replicate all of your infrastructure. That's a hard sell, and it's hard for me to say that. But at the end of the day, the thing that you're publishing on a website for other people to download should not be on the same infrastructure as people posting commits, being able to execute like arbitrary code on these build hosts. So another thing we say along with that password is like a compromised build infrastructure, which we expect it's going to happen with every commit, should not affect like the integrity of these packages that you're publishing. So why is this like even a problem? Like why are we thinking about this? This is 2015. We have tons of virtualization. Like this should be a solved problem. There should be no network access here. There should be no, like a build host should not be able to see any other build hosts. Agents should not do any type of network communication. It's really not the case. Like we're still stuck in a world where Jenkins is the best thing that we can use if you have to build like intense C++. If you're using like Python or Java or Node or something, pick a cloud CI. But if you have to run something yourself, Jenkins is designed to be flexible, extensible, which means like the controlling of virtual machines is actually a plugin that's added afterwards, just using this extensible API. And that means you're building agents that have no idea how to talk the virtual machine API. They're all using the agent-based framework that Jenkins runs, which is SSHing in and running a jar. So like, we need to really rethink if anyone has an opportunity to like rebuild CI, they should build it with like very, very hard constraints. Like you are using VMware, you are using ESX. Your authentication plugins are also completely extensible, completely flexible. They're not in there by default, so they're kind of dropping in using APIs. No, do not do that. Like either you're doing Active Directory LDAP with some Kerberos, or you're going to do OAuth and you're only going to support those two things. Do not make it flexible. Cool. So let's talk a little bit, I'll hand it back to you, about how that last point that we said, which is like isolate the two infrastructures, how we kind of accomplish that.
Bueno, primeramente, este fue el primer attempt que hicimos para construir esta infraestructura de integración continua. La idea fue que, como hemos comentado, la fuente de sabiduría, el source of truth, estaba en GitHub completamente, entonces ahí es donde guardamos todo el código. Lo siguiente es que cuando el código se envía a GitHub, viene ya sea una pull request o un commit en master, Jenkins lo va y lo construye, ya sea pull request o ya sea master. Entonces aquí, en la primera iteración que hicimos, Jenkins estaba directamente expuesto en Internet, teníamos alguna clase de protección pasiva, pero tampoco era una maravilla, y luego Jenkins tenía directamente acceso a la estructura virtualizada con los diferentes esclavos para construir el código. Esto está hecho con VMware, está expuesto a través de la máquina en AWS, Osquery.io, ahí tienes acceso a Internet, y desde la misma máquina de Jenkins publicábamos los paquetes en S3, que es donde los paquetes van, pues los repositorios, ya sea para Ubuntu, para CentOS, está todo ahí. Entonces, bueno, tuvimos que empezar a firmar paquetes y en el momento que empezamos a tener que tener una máquina en la cual vamos a tener que tener certificados y claves de firmado, ya tenemos que rediseñar esto, porque en este escenario un compromiso de Jenkins te va a hacer que pueda inyectar paquetes maliciosos de los que publicas, de los que usa la gente, entonces directamente eso es lo que estaría dentro del doomsday escenario. Y bueno, el código aquí va... En los slaves publicas en S3. Entonces, lo que hicimos, y estaría todo expuesto en Internet, lo que hicimos fue un diseño como un Jenkins duplicado, pero que no tiene comunicación ninguna, está en una VLAN completamente diferente, un sistema de virtualización separado. Entonces, básicamente, aquí lo que hacemos es, mismo procedimiento, código entra en GitHub, código que entra en GitHub, ya sea todas las pull requests que entran se construyen en el Jenkins que estábamos usando previamente, el Jenkins que está expuesto en Internet, que tiene acceso a sus máquinas esclavas con todos los sistemas que soportamos. Ahí se construye pull request y masters, pasa a las slaves, se compila en cada sistema, se examinan los resultados, se extraen metadatos y después esto simplemente es un entorno de integración continua. Es para saber si tu código funciona bien en todas las plataformas que se soportan. que es básicamente una de las ideas, uno de los requerimientos que teníamos antes de construir todo esto. ¿Qué pasa? Que vamos a tener que tener otra máquina que lo que hace es, va a GitHub, todos los commits que se han hecho en master, te los hace y te crea un paquete, te lo publica en S3, firmados, con unas claves de firmado. Y esta máquina es una máquina Jenkins que está aislada, no tiene acceso a Internet, tienes ACLs en la red para poder acceder a ella, tiene autenticación de 2 pasos, claves fuertes, o sea, es todos los pasos que necesitas para hardenear una máquina, eso es lo que hemos hecho aquí. Y lo que hace es, pues, publicas los paquetes en S3 y simplemente son todos los commits a master. Y básicamente, después de publicar los paquetes en S3, a través de ahí, en nuestro sitio osquery.io, puedes tener acceso a los paquetes, ya sea de OS X, los devs para Ubuntu 12 o 14, paquetes para CentOS, paquetes para Red Hat, y bueno, a través de todos ellos están firmados y puedes también utilizar los repositorios que tenemos creados para cada sistema. Entonces, la idea es, esta es la infraestructura que está expuesta y que tienes que asumir que va a estar siempre comprometida. Entonces, aquí, que te lancen shells, hombre, no le sienta bien a nadie que te lancen shells inversas en las máquinas que tienes que administrar, pero bueno, si tienes es un mal menor. Entonces, siempre vas a poder tener esta parte comprometida sin tener que afectar al resto de la infraestructura. Esta parte tiene una infraestructura de red completamente separada, tanto infraestructura de red como infraestructura de virtualización, y esto es lo que tendríamos como la parte más valiosa de todo este entorno, ya que si serían capaces de inyectar código de los paquetes que publicamos, sería bastante malo. Pero, aún así, el source of truth sigue siendo GitHub y, aunque nos comprometiesen la máquina... bueno, esto me parece que está en el siguiente slide. Entonces, un poco más de detalle dentro del entorno de firmado y de publicación de paquetes es, como hemos dicho, source of truth está en GitHub. Aquí entra en todo nuestro código, Jenkins lo construye, lo que hace es básicamente ejecuta los mismos jobs de construcción que estamos ejecutando en la integración continua, pero con creación de paquetes para cada plataforma que publicamos paquetes, y lo que hacemos es guardamos esos paquetes y aplicamos claves de cifrado, claves de firmado para esos paquetes y poder verificar que vienen de nosotros. Entonces, aquí lo que hicimos es, en el caso de que nos comprometiesen esta parte, podrían tener acceso a las claves de firmado. Por lo tanto, esto está metido en otro subgrupo que tiene a su propio nivel de aislamiento. Por lo tanto, en el peor de los casos que nos comprometiesen incluso la infraestructura, ya sea comprometer la infraestructura de creación de paquetes, o fuesen capaces de introducir código malicioso en nuestro repositorio de GitHub, no serían capaces de acceder a nuestras claves de firmado. Vale, este es el diseño fuerte que hemos sido capaces a través de ir probando y haciendo red teams, pen testing y demás. Y bueno, los paquetes se firmarían, se distribuirían por Internet. ¿Qué una cosa que es importante? Tienes siempre que monitorizar, porque que supongas que te van a comprometer la máquina no significa que te da igual que las tengas comprometida. Entonces, monitorizamos toda esta infraestructura.
Excellent. Yep. So what does Osquery actually look like? If you were to install it and drop into the shell, you can kind of run SQL here. Here I am looking at all the listening ports that are on the machine. Here I am doing a join from listening ports to processes. So now I see all the names of the processes running. This is actually on my machine, and I am running Better Touch Tool, which just lets me macro windows back and forth, but it also binds to every interface on 000. It's horrible. I hate that tool, but like, hey, yeah, what are you going to do? So on all of that infrastructure, we can run this shell in kind of like a daemon mode, so it continues to run queries and continues to get results into a log, and then we pull that back. On all this infrastructure, we only schedule one query, which is watching all the processes that happen. So we get like the path to the binary that was executed, all the command line arguments, and then the credentialing material, and some like create modify time around the file that was executed, the binary that's being executed. And we run that every 60 seconds. So on all this infrastructure, every 60 seconds, all the process events that have happened get logged. We pulled that back into a little log stash, and if you check out, we had a BrewCon workshop which details how to set up and install all of this so you can get it up and running. And there's also tutorial links down here when we publish these slides. So we take the pull request Jenkins, that entire infrastructure, we take the isolated package building Jenkins, as well as that AWS proxy and the couple of signing hosts there, and we look at all the processes that are executing here, and we pull them all back into one place. So the Logstash configuration too is pretty quick and easy for Osquery. If you dump these two things into the right files, you'll get up and running. All of the Logstash will have parsed all of these command lines, the paths, all the credentialing material out for you. So you can build things like dashboards where you can sort and distinct count all of the paths, or distinct count all of the command line arguments, and then count them in descending order. So the things that are going to be are in ascending order. So the things that are going to be at the top will be the processes that ran like only once or twice or 3 times. This is build infrastructure. It's running the same thing every time a commit happens. It's running the same thing every night to build packages. All of those commands run a ton of times, and if you're ascending, they're all going to show up at the bottom. So the things that are going to show up at the top are going to be these like attacks, right? So, and if anything goes out of the shell, if anything launches a shell, if anything tries to touch any of this infrastructure too, we're going to log it within 60 seconds, right? So anything that happens there, like, awesome. We'll be watching that, and then we can take action afterwards. And this is exactly how we use Osquery across all of Facebook's infrastructure too. That descend sort, plus also looking for like indicators of compromises, weird SSHs, weird accounts, like all of that is how we do incident response. So in conclusion, like if you have to run Jenkins or you see people running Jenkins, take very extreme care of it. If you are doing an assessment and you see a Jenkins, you probably already know that that's going to be your way in, or that's going to be something to focus on. And it's going to be really important to provide feedback to your clients, your customers, that like they need to harden that. That is going to be the thing that they're running all their security analysis through, that they're probably cutting packages with, right? That thing has to be super, super locked down, as well as like audit everything that's on there. Before a build host gets turned off in build infrastructure, take all the logs back. Like, please put that somewhere that you can aggregate. And then if possible, like push all the authentication and all the databases off of Jenkins. Like, do not let Jenkins maintain an authorization database. Push that into something like Google, push that into something like GitHub, right? And then if you're interested in assessing our infrastructure, doing the same kind of things that we showed here, please let us know. We have a white hat program, and all of Osquery plus our infrastructure is included in that. So if you find 0 days or anything in Jenkins too, you can report it to us. Like, hopefully you'll get paid out too. Awesome. Thank you so much. Any questions?